Now you have seen how to write UVM based transactions and UVM based sequences. So as I said earlier, these are the only part of your UVM based test bench where you will write the stimulus behavior. So, and your stimulus behavior have no connection or no dependency on your test bench structure, and that is the advantage of UVM. UVM separate the stimulus from the test bench component hierarchy or test bench structure. So here is your UVM stimulus generation part, which contains sequences and transactions, and the other side, the the test bench behavioral side part, you will write UVM environments, UVM agents, and within UVM agents you will write these components. Now next you are going to see how to write a UVM agent, which is consisting of a UVM sequencer, UVM driver, and UVM monitor. Now you're going to write the UVM agent and its associated components, which are sequencer, driver, and monitor. To make the test bench simple, we are not going to write the monitor part here. Whole test bench is not doing any checking part, it is just writing a stimulus generation part. So here we'll be writing the UVM agent with a sequencer and the driver. If at all you were writing a monitor part, this is where you would have written it. Also, if you want, you can split different class definitions into different separate files. Now coming to the first part, which is the sequencer. So first we will write the sequencer, then we will write the driver, and finally we will write the agent. So this is your UVM sequencer. Your AXI write address sequencer is extending from the UVM sequencer, and it should be parameterized with the type of transaction which it is dealing with. So here it is AX transactions. So the first argument and the second argument should be the type of transaction that is sending from the sequence to the sequencer or the interface, and the response, and the second argument is the type of the response transaction. In most of the cases, both will be the same. And the next line is the UVM factory registration macro, which is UVM component utils for all the classes which are derived from the UVM component class. So agents, driver, sequencer, monitor, other components, environments, and even test should use the same factory registration macro, which is tick UVM component utils. And next is a new function, and next is a build phase function, and next is a run phase function. So as you have seen previously, these were the build phase and run phase functions were standard UVM phase functions which are present in all the component classes. If you had some other subcomponents within this class, you should create those subcomponents within the build phase function, and the run task is a task where you will write the intelligence of this particular class. In case of UVM sequences or Uveron sequences, most of those sequences will be exactly same as that of a base UVM sequencer. In this case, as you can see here, the run phase task and the build phase function is just empty. There is no intelligence that you have added here. So this will be the case for most of the sequencers that you are writing in UVM. Therefore, you can write your either you can write your sequencer as shown here with these functions, or even if you just delete these things functions, it will work exactly the same. And another easy or simplest way is just adding a type def for this UVM sequences to your own sequencer name. So this is the type def statement. Type def UVM sequencer parameterized with this type of transactions, and give your own sequencer name. So here AXI write address sequencer. So this statement and these class are exactly the same. So typically you will be writing only this type statement, but as a beginner you can practice writing the sequencer so that you will get a feel that you are writing a sequencer within an agent. So here is your UVM sequencer. So next is your UVM driver. Again, the UVM driver is extending. Your own UVM driver, which is a AXI write ADDI driver, is extending from the UVM driver, and it should be parameterized with this type of transaction which is dealing it. In this case, it is AXI underscore DXN. And next is the factory registration macro, which is UVM component utils. And as in the case of a driver is a UVM part, a UVM class which is interacting with the DUT. So it need a handle of the DUT through which it is it need a handle of the interface in the DUT through which it will send transaction into the DUT. Thus we are adding a virtual AXI write ADDI interface instantiation like MINDF. This was exactly same as that you have seen in the case of a simple Systemverilog class-based test bench. And next is the new function. The new function in case of all the component classes are little different from the data classes, that is the transaction and sequence classes. Here it will have two arguments. First argument is an optional string name, and the second argument is the UVM should be a UVM component class and with name parent. So, and immediately after the first line you should call super.new with this name argument and parent argument. And if you wanted to add extra intelligence to these new functions, or so if you wanted to initialize something to here, you should add only after this super.new function. And this new function will, and this build phase function will be similar for all the component classes. Again, there is nothing in this build phase function because there is no other child component to this class, driver class here. And also you might have noticed that to this build phase and the run phase functions and tasks, you are passing an argument with which is of type UVM phase, and its name is phase. So you don't worry about this at this point. As a beginner, you just remember that to every build phase and run phase methods, you need to pass this UVM phase argument. And after this, you don't need to use it anymore within these classes, but you just pass it here as a UVM phase argument. And next is the run phase task, where is the actual intelligence of this particular component lies. So in this case, this is a driver, and it should drive transactions into DUT. When you have completely written an UVM based test bench, all the run phase tasks of all components will be called at time 0. So this run phase task and any other run phase task sitting in any other component will be called at immediately at simulation time 0 itself. And so now if you go through this code, first you will check whether this interface handle is null and flag an error, and then you should initialize the reset value of any of those driving signals and wait for a reset, and then you should actually start injecting transactions into driver. So after this, you will be starting a forever begin block infinite loop where you will take a transaction and drive it into the DUT. Now the question comes here, how do we get a transaction into this driver? So this is how you get a transaction in the driver, like seek item pod dot get next item. Again, this is specific to UVM. As a beginner, you just understand that you just need to use this statement like seek item pod dot get next item to get a transaction. And once you got a transaction, you can drive it into the DUT. So this task is specific to the user. So here I have explicitly written this task to drive this signals, which is similar to your previous drive ADDI tasks that you have seen in the simple SV test bench. Also notice that I have used the took UVM info macro instead of a $display statement here within this drive task. And once you have driven this task, note that there are no loops here. This is just driving this this particular transaction into the interface. And after I've completed this transaction driving, I've used another statement like seek item port dot item done. Again, this line is specific to UVM. You just remember that you need to add this this line after completely driving the transaction into DUT. So you have completely written your driver class, and just to summarize your driver class, the special cases or something that you might need to wanted to give an extra care here is the run tasks, where after your initialization checks and driving parts, you might wanted to be in a forever loop within that driver, because whenever a sequence is sending a transaction into the sequencer, you will get the transaction in the driver. That you will see how we are getting that later, but whenever you're getting a transaction, you should be able to drive it. So your driver will ideally be in a forever loop, and these two lines, like seek item dot get next item, is a blocking task, which will block the execution until you have a valid transaction being received in the driver, and next you will drive the transaction according to your DUT specification, and after driving you need to write seek item dot item done.